Hi, welcome to AM20602. So, so in this session, we're going to talk about a method of consistent deformations using force method. For for this topic, we're going to fulfill the course outcome number one, which is the ability to illustrate in internal member forces diagram for indeterminate structural system by using method of consistent deformations. So basically, students should be able to draw a shear force diagram and bending moment diagram. But to develop that diagram, you need to solve the forces and moments using this method of consistent deformations. So let's start with determinacy. So determinacy is when all forces in a structure can be determined strictly from these equations, the three equations, x, y, and moment. So the structure is referred as statically determinate. So you can determine all the forces using on the three equation, the equation on x-axis, y-axis, and then the equation of moment. Structures having more unknown forces than available equilibrium equation. So you have more forces than the equations. We call them the statically indeterminate. So which is R is equal to 3n. If R is equal to 3n, then you have a statically determinate structure. But if your R is more than 3n, it becomes statically indeterminate, when your forces is more than the number of so R is the number of unknown forces, basically reactions. You don't know reactions forces. When the beam is attached to supports, there's a reaction on the contact between the structure, the beam, and the supports. So n is the number of members. If you have a single beam, then it become a one member. But if it is like trusses, then you have a combined trusses, then the members becomes based on the number of trusses. So based on this example, we can do some refresher on determinacy. So for example, on for figure A, we have R equal to 3, R equals to 3, N equals to 1, because R is the reactions. If you see here, there's reactions on reactions at the pin support on the left, and then roller support. So you have one unknown forces at roller and two unknown forces at pin joint. Then you have, so your R is equal to 3 and your N is number of members, so it's a single beam with cantilever beyond the roller support. So you have N is equal to 1, so you have R equal to 3 times N, which is 3 equals to 3 times 1. So it is a determinate structure. Basically, you can identify, you can evaluate, you can know the value of reaction support at the support. As you can see in the force diagram at the right. Another example on figure B, uh, R is equal to 5 because you have three supports there. You have fixed and roller and roller. So at roller you have one each. So in there you have two. At a fixed support you have moment and a reaction force on y-axis and reaction force on x-axis. So total up you have R equal to 5, and but you have only one member. So 5 is more than 3 times n, 3 times 1. So you have 5 larger than 3 lah. So it is a statically indeterminate to the secondary degree lah, because you have 5 unknown, but you have only 3 equations. So you have you need another 2 equations to solve. the problems. So then it becomes a statically indeterminate to secondary degree. So why do we need to distinguish between these two? Because if it is indeterminate to first degree, then in the force method you need to add one forces. But if it is indeterminate to second degree, then you need to add two forces. So a lot more equations and a lot more diagrams need to be developed